In this video, we are precisely looking at calculations involving oxidation numbers. Look at the first question. The oxidation state of chlorine in this compound is, what will be the oxidation state of chlorine? Before you rush to choose -1, it is true that chlorine is in group 7 and hydrogen. It is possible or more readily possible or feasible for chlorine to gain 1 electron to complete octet than it to lose that 7 which it already has. Before you rush to choose -1, do your calculation, because there are some possibilities where chlorine would have a +7. It doesn't mean that chlorine is losing 7 electrons. This is a covalent compound. It means that chlorine is more electropositive. Chlorine is more electropositive. That is why it will be +7. That is if at the end of the day we calculate and then we have a positive value. Let's proceed. Since it's a neutral compound, or a compound is not an ion, that means the charge is 0. And if I add from the rule, that is rule number 4, if I add oxidation number of hydrogen plus that of chlorine plus that of 4 into oxygen, I'm going to get 0. That of hydrogen is +1. This is not a peroxide, so obviously that of chlorine is what I am looking for. This is not an hydride, so that of hydrogen will be +1. That of oxygen will be -2 because this is not a peroxide. So this is 4 into -2 giving me 0. So +1 plus chlorine -8 equals to 0. Make chlorine to stand alone. Cl equals 0 minus 1 plus 8. Of course, 0 minus 1 plus 8. 0 minus 1 is -1 plus 8 is +7. So the oxidation state of chlorine in this question would be +7. You see that now. So in this compound, the oxidation state will not be -1, not -5, and not +1. Let's go to the second question. The oxidation state of carbon in this compound is, this is metanoic acid. Because it's a compound, it's not an ion, oxidation number of hydrogen plus that of carbon plus that of oxygen plus that of oxygen plus that of hydrogen will give me 0. I have 2 atoms of hydrogen, so it will be 2H plus that of carbon plus O is 2O equals to 0. This is oxygen. This is 0. They don't mean the same thing. So this is 2 into 1 plus that of carbon plus 2 into -2 equals to 0. 2 times 1, I have 2 plus that plus 2 times -2 is -4 equals to 0. So from here, I can just make carbon to stand alone. Carbon equals to, take 2 to the other side, take minus to the other side. So it's 0 minus 2 when 2 crosses plus 4. This is minus 2 plus 4. So this is plus 2. So the oxidation number of carbon here is plus 2. Now note, even though carbon is in group 4, that it will either lose 4 electrons to have oxidation number of plus 4 or gain 4 electrons to have oxidation number of minus 4. There are a few cases where the oxidation state of carbon is plus 2. This is why it's always important to apply the rules to do your calculation. Let's proceed. Question number 3. The oxidation number of Mn in the radical, this is, the name of this radical will not be called out to you. If the name of this radical is called out to you, it will be easy to know the name of that, the oxidation of that atom. Of course, we have done this example before. This is tetraoxomanganate 7. But you would not be given the name, it wouldn't be written out. It will just be given, the chemical formula will be written like that. This is not a compound, but it's an ion, because I have a charge there which is not 0. So how am I going to find this? Remember, this is a polyatomic ion. If there is no other thing you should learn in addition, as you're watching this example, is that a polyatomic ion is also called a radical. What's a polyatomic ion? An ion consisting of more than one element. What's a radical? A radical is a group of atoms coming together to react as a single unit carrying a charge. Carrying a common charge. Group of atoms coming together to react as a single unit carrying a charge. That's a radical. It's another term or word for polyatomic ion. Apply the rules, because the polyatomic ion is an ion, rather, polyatomic, that's still correct. The algebraic sum of the oxidation numbers is equals to the charge, and the charge is minus 1. So this is that of manganese plus 4 into oxygen minus 2 equals to minus 1. So this is plus 4 times minus 2 minus 8 equals to minus 1. That of manganese will be minus 1 plus 8. Minus 8 crosses over. And doing that, I will have that manganese is plus 7. That is the oxidation number of manganese, and of course, our answer is D. Our answer is D. That will be the oxidation number of manganese. Let's go to example 4. Question 4, or example 4. Which of the following reactions does reduction take place? Which of the following reactions does reduction take place? Is it this? Is it this? Is it this? Or is it that? In the left hand side, if you see minus 2e, that means minus is a loss. When answering questions like this, pay attention to the left hand side. Depending, you can also be confused with putting something like that in the right hand side too. Right? But pay attention to the left hand side. This is minus. That means that chromium atom is losing 2 electrons. Look at this, hydrogen ion. This chromium is at ground state. There is no charge here. It's at ground state. That is the electron. The oxidation number here is 0. Look at this. Plus 2e. That means that hydrogen atom is gaining electrons. Yes. Look at this. Minus e minus. That means this is losing. Minus is losing electrons. Look at this. This one, I'm not seeing anything in the left hand side, but I'm seeing a plus 4e minus. That means this atom is gaining 4 electrons. in the right hand side. Plus in the left hand side is not the same thing as plus in the right hand side. But let's read the left hand side first. In these three cases rather, this is a loss of electron. Reduction. Oxidation is a loss of electrons, while reduction is a gain of electrons. So in the left hand side, this is oxidation. This cannot be the answer. This is oxidation because it's a loss of electrons. Look at this in the left hand side. In the left hand side, this atom, loss of electron, this is oxidation. This cannot be reduction. So this is oxidation. Oxidation, this is oxidation 2. Remember in our video on redox reactions and atomic structure, I had said that if an atom loses electrons, that process is oxidation. That means the oxidation number increases. The oxidation number here is 0. After it lost 2 electrons, it increased from 0 to what? To plus 2. Oxidation brings about increase in oxidation number. Oxidation number here is plus 2, lost 1 electron, increases to plus 3. This one lost 2, increases to plus 2. Lost 1 from plus 2 increases to plus 3. This is oxidation. But look at this. This is a gain of electron. Gain of 2 electrons. Oxidation number here is plus 1, 2 moles. 2 moles of that. Alright, that means the charge is plus 2. So 2 times plus 1, it will give me plus 2. It will gain 2 electrons. 2 electrons has a charge of minus 2. So plus 2 plus minus 2 is plus 2 minus 2. That gives me 0. That means that the charge of hydrogen here is what? 0. Of course, I'm not seeing any charge here. That means the ground state is 0. So the charge reduces from plus 1 for the 2 moles. That's plus 2 to what? 0. And reduction is accompanied by a decrease in the charge or oxidation number, and reduction is gain of electron. So this is reduction. Reduction. Alright, if you look at this option D, I did not see any plus gain or loss in my left hand side, but I'm seeing electrons in my right hand side. You can also represent this as this. Take this plus 40 to the other side. So it will be 2 or 2 minus, plus 40 plus minus 4e, giving us O2. So you can see this here. I brought it to my left hand side, and it is looking exactly as this atom lost electrons. So this is also oxidation. Oxidation. So this is another way of representing this. So the correct answer that portrays reduction is option B. Option B is the correct answer. Yes. Question number 5. What are the possible oxidation numbers for an element if its atomic number is 17? If atomic number of an element is 17, of course that element is chlorine. What's the other way of knowing that? The first shell I will have 2 electrons. The second shell I will have 8 electrons. That's a total of 10 electrons. And then the last shell, how many electrons remains? Because atomic number is the number of protons, and at ground state the number of protons is equal to the number of electrons. So at the last shell I'm going to have 7 electrons. So, or you can also do this. 1, 2, 3, 4 pairing. 5, 6, and what? 7. So in the outer shell of this electronic configuration, I'm going to have 7 electrons. That means that this element is in group 7. If this element is in group 4 in the periodic table, it means that this element in a chemical reaction will lose 7 electrons, or it will gain just 1, to add it to become 8. So, going forward from there, if it loses 7 electrons, the oxidation number will be plus 7. If it gains 1 electron, the oxidation number will be minus 1. So the two possible oxidation states of this atom is either plus 7 or minus 1, which is option A. So, I believe you were blessed and your understanding was clear regarding these oxidation numbers. Make sure you like, make sure you subscribe, and make sure you share. Click the notification bell for more videos that will be coming up in this channel. Thank you so much. See you in